just go and jump into our first question. Okay, cool. So the first one is question 1, like as usual. Question 1 is basically algebra. It's all concepts that you've learned in algebra from as far back as grade 9 even. We're trying to test if you are able to solve equations, inequalities, simultaneous equations, and laws of exponents are also very important when you're working with these kinds of questions. So the first question is asking us to solve for x. In 1.1.1, they say solve for x if x squared, right? Minus 6x is equal to 0, okay? So this is a quadratic equation. If you didn't know, from an equation like this, we're expecting to get 2 solutions. So it's an easy question. What you need to do is just take out a common factor here. It's x into x minus 6 is equal to 0. Using the 0 factor law, when you multiply 2 things, and the answer is 0, either the first one has to be 0 or the second one has to be 0, which means x will then have to be equal to 6. It's not complicated. It's very simple, straight to the point. All you had to do is just take a common factor out and then use the 0 factor law to find a solution to this. All right, cool. Let's go to 1.1.2. Now, in 1.1.2, I want to highlight something very important about that question. 1.1.2, again, we're still trying to solve for x. Now, there's an important instruction that the examiner put just next to the question where they say to you, you need to leave your answer correct to 2 decimal places. Now, this is kind of like a giveaway. It tells you that your solution can't be solved by just simple factorization, which means what you need to do is use the quadratic formula. So if you check there, we need to know what the a value is. Our a value is 1, and then our b value is just simply going to be positive 10, and our c value is just simply positive 8. Now, the quadratic formula says x equals negative b plus or minus the square root of b squared minus 4ac, where everything has to be divided by 2a. All right, now let's substitute the values of a, b, and see what is going to happen. So what we're going to have here is negative of positive 10 plus or minus the square root of. Now, please don't do this. Don't put 10 squared like this, because you're going to get used to doing a wrong thing. All simplifications that require substitution need to have the numbers in brackets, because if that number was a negative, it would give you a different result if it didn't have a bracket. So always make sure you use brackets. Your a is 1 and your c is going to be positive 8. Everything has to be divided by 2 times a, and our a is equal to positive 1. Okay, now I want to highlight something very important here. Negative 10 is just negative 10. I want to work out the value of the number that is inside the square root sign, because when you're watching this shows, what we always try to do is help you understand beyond what the question was asking. So 10 squared is 100. 4 times 8. So what I'm looking at, I just want to work out the number inside the square root sign. You've got 10 to the power of 2 minus 4 times. Your a is 1 and your c is positive 8. You will see that we're getting the answer 68. That's the number that we're getting here, 68, right? Divided by 2 times 1, which is 2. Let's just focus on this number, which is 8. 68. It is not a perfect square, right? And it is positive. The fact that it's positive tells us that since it's a positive number, we are going to get an answer. If it was a negative, then we were going to claim that the roots of this equation are non-real. But because of the fact it's a positive, we are going to get a real answer, right? We're going to get real solutions, okay? And the fact that it's not 0, we are going to get 2 unequal numbers. It's actually part of what you would need to know when you're working with nature of roots. And for the fact that it is not a perfect square, it means that the roots are not going to be nice numbers. Remember the following: if the number that is inside the square root is a perfect square, it means you're going to get a nice number. Nice numbers are all positive numbers or all negative numbers that are whole, which is integers, or any other thing that is a fraction. So it would be rational. But if it's not nice, it means it's something, something else. We say that kind of a number is an irrational number. And that's what is going to happen in this question. So our answer is going to come out as an irrational. Irrational means not rational, which means not nice. Not a fraction, not a whole number, either negative or positive. So let's go to our calculator and try and figure out what the solution is going to be to this question. Okay, cool. So I will work out the fraction. There's our fraction pattern right there. And then you have to put on top that negative 10, all right? And then plus square root of 68. Everything needs to be divided by 2 times a, which is 2. My first answer, they said to 2 decimal places, not in short form. Changes to negative 0. 0. What is it? It's negative 0.88, negative 0.88. Or the other x value is the one that you'll get when you change the sign from being a positive to being a negative. So go back, and then you press the backspace button, you put a minus there, then the answer comes out as negative 5 minus the square root of 17, which when you press the change button there, it gives you negative 9.12, negative 9.12. Okay, negative 9.12. That should be the solution to this question when you round it off to 2 point. Let's look at root 2 1 instead of writing 12. Okay, fine, negative 9.12 instead of negative 9.21. Let's fix that quickly, and then that should be the answer, the solution to this problem. The key here was, remember, to round off the answer to 2 decimal places. In that case, it means the examiner has helped you to know that the solution to this problem can be achieved through using the quadratic formula. Right. Let's go to the third question. It says we need to find x values in this inequality. That's an inequality. Now, be careful about this inequality because of the fact that the x value there is not positive, but it's negative, right? So let's look at it. It's 1 minus x and x plus 1. 1 minus x and x plus 1 less than 0. Okay, cool. So let's see what will happen in 1.1.3. So if 1 minus x into x plus 2 is less than 0, and I ask you to find the solution to this, which is an inequality, how do you actually approach this question? Number one, you are likely to make a mistake if you are used to working with these kinds of questions. You will notice that the solution to this is going to be an upside down parabola instead of a smiling face parabola if I'm using the graphical method to find the solution. The critical values are not difficult to work out, right? The critical values are not difficult to work out. One critical value is going to be positive 1, and the other critical value is going to be negative 2. But because of the fact that the x here is a negative, my graph is going to come out as an upside down parabola instead of a smiling face parabola. And what does the examiner want? They want the solutions where this product is less than 0, which means where it is negative. Now, when you look at this graph, where is this graph negative? The graphs that we work with are always negative below the x-axis. Remember, guys, this that you're looking at here in yellow is the x-axis. I don't need to worry about the y-axis. I'm just interested in these x-axis. So the graph is negative below the x-axis. Above the x-axis, the graph will always be positive. And then below is going to be negative. Remember, the critical values would be here and the other one will be here. So this will be my negative 2 and this one will be my 1. So big question, where is this graph negative? Where is it less than 0? So this graph is less than 0 for all x values that are before negative 2 or all the x values that are after 1. Before negative 2, which means on the left of negative 2, that's where the graph is negative, which is this part here. And then after 1, as you're looking at it from left to right, after 1, the graph is also negative. Now, why would this question be confusing? Because you guys are used to working with smiling face parabolas. The other way you could have done it is by multiplying those two brackets together. If I break those two, I would get 1 times 1. And then I will get 1 times 2, and then negative times x, and then negative x times x, and negative x times 2. But the best way of working at it could be looking at the first factor. Let's put it here in green. 1 minus x, okay, into x plus 2 is less than 0. The common factor in the first bracket could be a negative. When I take out a negative in the first bracket, I'll get x to be positive, and my 1 to be negative. I'll have x plus 2 is less than 0. Now, we've got a negative that we don't like working with, so I will divide both sides by negative. Remember, when you divide by negative, the inequality will change direction. That means we'll end up with x less 1 into x plus 2 is greater than 0 instead of less than 0 because I'm now dividing by a negative. Now, this one that you're looking at, x times x here, would produce a positive product, which means the graph that you would be working with now would be a smiling face parabola because the product of x and x will be positive x squared. Your critical values are still the same. it's negative 2 and 1. But now we are no longer looking where the graph is negative. We are looking where the graph is positive. Where are graphs are positive? Graphs are positive above the x-axis. Graphs are positive above the x-axis. So that's all x values before negative 2 or all x values after a 1. And that's how the solution would be for this beautiful inequality that you have. Just be careful to make sure that you're not dealing with a set phase parabola when you're solving inequality questions. A beautiful question indeed. Right, let's move on to the next one quickly. The next one says the square root of x plus 18. The square root of x plus 18 equals to x minus 2. All right, cool. Quickly, the square root of x plus 18 equals to x plus 2. Is it plus or minus? Let's just confirm that quickly. You have to also make sure that you're copying questions correctly, because if you don't copy questions correctly, you're likely to make mistakes. So x minus 2 is what you're looking at. And that is our question 1.1.4. Awesome stuff indeed. Right. So the first thing that you need to work with here is remove this root sign. How do we do that? We do it by squaring on both sides. If you square on both sides, you'll get x plus 18 on the left, and on the right hand side, you get x squared minus 4x plus 4. Don't make a mistake of only squaring the x and the 2. This is a binomial squared. It always produces a trinomial. Add like terms, you'll get this minus 5x when you subtract x on both sides. And then when you subtract 18 on both sides, you'll get negative 18 plus 4, okay, which will eventually leave you with x squared less 5x minus 14. Now, that is an easy question to factor as beautiful mindsets. You just subtract a 7 and then you add a 2. One answer is 7 and the other answer would be negative 2. So very simple and easy, as long as you understand that this is what the solution is going to be when you factorize. But because of the fact that you're dealing with surds, this is a surd question, you don't just leave your answers at 7 and negative 2. It is very important to make sure that you check if your answers are both valid. There's a high chance that one of them is not valid. There's also a high chance that none of them are valid. So you must resubstitute them back into the equation and check if they satisfy the equation that you're working with. After that, everything else should be fine. Okay, cool. So let's see when we test 7. Now, I'm going to test 7. You don't have to show this to us. But if I check, I'm going to check here, right, in this beautiful box here. When I check 7, you put 7 wherever you see x in the original question. It will be the square root, right, of 7. That's what I'm substituting as my x value, okay, plus 18, right, equals to, your x should be 7, so 7, okay, minus 2. Now, 7 plus 18 is basically 25. The square root of 25 is equals to 5. So is 5 equal to 5? Yes, 5 is equals to 5, so that means that's the solution. I'm happy with the answer 7. I'm going to consider it as a solution. Now, let's check the second one. We're now going to check the one negative 2. If you check negative 2, we'll check it in this box here. We're checking negative 2 in this box here. You just have to substitute negative 2. It's going to be negative 2 where inside the square root sign, and that has to be added with 18, all right? And then that should be equal to, your x value is negative 2, and this is supposed to subtract a 2. So what you notice on the left-hand side is 18 less 2 gives you 16. The square root of that gives you 4. But on the right-hand side, you have negative 4. So 4 and negative 4 are not equal. So this is not a solution. So then you have to come back here and disqualify this as a solution. So the only answer you have would be 7 and not negative 7. It's always important to make sure you double check your answers and make sure that the answer that you are giving to us are not incorrect. So the other one is correct, the other one is not correct because it does not satisfy the equation that you're working with. A beautiful question indeed, absolutely awesome. Let's go to the next one. Okay, cool. So this one is a simultaneous question. Let's look at it quickly. It's asking us to solve for both x and y. I'm going to go through it quickly because you guys have got working knowledge of how to deal with simultaneous. So one part is x plus y, right? One part is x plus y. So we've got x plus y equals to something. What is something? Let's look at it. It's actually equal to 3. Right, x plus y equals to 3. Right, so x plus y equals to 3. All right, and then the second equation says to us 2x squared plus 4xy, okay, 2x squared plus 4xy, all right. Make sure you copy the questions when you're dealing with these things, because you might make mistakes because you're not copying the question correctly. Minus y equals to 15. Okay, 4xy minus y equals to 15. Minus y is equals to 1 and 5. So two equations as usual, equation 1 and equation 2. We want you to find the value of x and y simultaneously. So I'll take the first one, the linear one, and make either y or x the subject to the formula. If I make y the subject, I'm going to have y equals to 3 minus x, okay? That means wherever I see y, I'm now going to replace it with 3 minus x. So that's what I'm going to do. So let's look at that. I've got 2x squared. I'm going to rewrite that. There's my 2x squared. There's plus 4xy. There's 4x. What is y? Like I said, everywhere you see y, you're going to change and write it as 3 minus x, okay? Then there's minus y, which again, I'm going to replace it with what? With 3 minus x. The only thing changing is the y value. Everything else needs to stay exactly the same. Did I forget something? Yes, I forgot something. What is it? Go back to the question and check closely. You will notice that this is actually 2x squared plus 4xy minus y equals to 15. Okay, 2x squared plus 4xy minus y equals to 15. So let's try and simplify this and see what is going to happen. On the first one, I've got 2x squared, which is quite cool, 2x squared. Now I must multiply this and that. I'm going to get positive 12x. And then when you multiply this one with that, it gives you negative 4x squared. Okay, and then I'm going to have negative 3 here, and negative is going to give us positive x. And then you can immediately subtract 15 here. You'll get an answer of equal to 0. Okay, cool. Then after this, we just need to simplify by adding like terms and seeing what we're going to end up with here. Now, it looks like this is friends with that, okay? You're going to get negative 2x squared when you add them. 12 and 1 is positive 13x. And then you'll see that negative 3 and 5 is actually going to be negative 18 is equal to 0. For some weird reason, I feel like that 3 minus x of y was supposed to be a y squared. So sometimes when you're working with this thing and you feel like something is not right, it always helps you to keep checking to confirm that indeed you have everything the way it should be, right? Okay, so I've got what I'm looking at. I'm happy about what I have. But again, like I said, you have to make sure that you're solving for both x and y and you didn't copy anything incorrect. Someone might have expected that we'll have a y square there, so you have to keep checking to make sure that we don't have a y square. It is indeed a y and nothing else. So now that I see it's actually a y, I'm happy. I'm now going to continue and simplify it. So it doesn't really hurt to keep going back and checking if your answer is actually correct. Okay, now I don't like the negative 2 that I have, so I'm going to divide everything by negative 2. I'm going to get 2x squared minus 13x plus 18 is equal to 0, dividing everything by negative. So let's try and factor this out. I've got 2x and x, that is going to give us 2x squared equals to 0. I needed 13. Factors of 18, I could use 18 times 1, but that will not get me 13. I could use 9 times 2. I could use 6 times 3. I needed 13. If I have 9 times 2, it's going to be a 9 and a 4, which will give me the 13 that I'm looking for. But I need my 9 to be here, and I need my 2 to be here. They must both be negative. Okay, y, negative 9 and negative 4 will give you negative 13, and you get your positive 18 when you multiply those two numbers. One x is 9 halves, and the other x is a 2. Right? Once you've got those x's, you're going to get your y's by going back and resubstituting in that equation where y equals to 3 minus x. So the one is going to be y is 3 minus 9 halves, or y is 3 minus 2. This one is easy. The answer is going to be 1. But the second one is actually 6 over 2 minus 9 over 2, which is going to be negative 3 over 2. Then that's the solution for both x and the other y value, which is a 1. Now, the last question was a very serious question, guys. Very, very serious. It's what we call problem-solving questions. They're not so easy to work with. They require you to think deep about what is in front of you. We are given that if n is the largest integer, right, for which n to the power some number 200 should be less than 5 to the power of some number 300, okay? N to the power 200 is less than 5 to the power 300. Okay, let's put it down. So n to the power of 200 should be less than 5 to the power of 300. So we're asking you, what is the integer value, the largest integer value that will satisfy this equation? One n value that we can think about is 1. Obviously, this is just me thinking with you guys. 1 to the power 200 is indeed less than 5 to the power 300. And 2 to the power 200 could probably be less than 5 to the power 300. So we want to know, what is that integer value that you can have that will satisfy this particular inequality? All right? Now think about it. Let's just try to get the exponents to look the same. We'll try and get the exponents to look the same. What is the answer going to be? Well, I'll have my n to the power of 200. I'm leaving that here. N to the power 200 will be less than. I want 5 to the power something. 5 to the power something. And I want the outside exponent to also be 200. I want my exponents to obviously look the same. When they look the same, I think I will be able to deal with the number inside. It will help me to see how the answer is going to be. It will help me to see what is the legal integer value that I can have that will satisfy this condition. So the outside exponents are both 200. So I want to know what number times 200, what number times 200 will take me back to that 300 that you have there, right? Let's just call it x. So some number multiplied with 200 should give us 300, okay? And then that number is actually going to be 3 halves, okay, if we divide both sides by 200. Now that means the new exponent that I need to have there should be 3 over 2, because 3 over 2 times 2 will give you an answer of exactly 300 at the top. Okay, so then after that, you can just take your calculator. You'll notice that since the exponents are the same, 200 and 200, my n should be a number that is smaller than 5 to the power 3 halves. You can take your calculator and even work it out. Just ask yourself, right? What is 5 to the exponent fraction 3 divided by 2? You'll get an answer of 11.18. So that means n is a number that is smaller than 11.18. So what is the highest possible integer value that is smaller than 11.18? That will tell you that n has to be exactly 11. It means all the other integers before 11 are also going to produce a number that is smaller than 5 to the power 300. But the highest one will be 11.